Here's another example of simplifying a complex fraction using method 2. Here I've got 1 over x plus 2 plus x all over x over 3 minus 1 over 2x plus 4. So the very first step, if we're using method 2 to simplify a complex fraction, is to identify the least common denominator among all of the fractions within the complex fraction and multiply the numerator and denominator by that. So we have three fractions here. One of the denominators is x plus 2, one of the denominators is 3, and the other denominator is 2x plus 4. To figure out the least common denominator, I'm noticing that this denominator is not in factored form, so we've got to start by factoring that denominator in the second fraction in the overall denominator of the complex fraction. So let's just keep the numerator the same, 1 over x plus 2 plus x, and I'm keeping the x over 3 the same. All I'm doing on this step here is factoring the 2x plus 4. So we can factor out a common factor of 2 there from both of those terms, and that would leave in parentheses x plus 2. Okay. So all denominators are in factored form. We can figure out the least common denominator here. So the least common denominator, looking at an x plus 2, a 3, and a 2 times x plus 2, it's always the least common multiple of the denominators. We've got a 3 and a 2. So the least common multiple of a 3 and a 2 is 6. So 6. And we also have an x plus 2 in each of these denominators. So we need an x plus 2 for the LCD, for the common denominator. So the numerator and denominator of this complex fraction need to be multiplied by 6 times x plus 2. And I'm showing that here. Okay. So the next step, after determining what the common denominator is and showing that you're multiplying the numerator and denominator by it, is to distribute it and then simplify the numerator and denominator. So we've got at this stage 1 over x plus 2 being multiplied by 6 times x plus 2. And if you can do this step in your mind, that's great. I'm just going to show it here. And then plus x multiplied by 6 times x plus 2. To make that look a little more standard, instead of writing x6, I'm going to write 6x. So 6x times x plus 2. Okay. So I distributed the common denominator there to both terms in the numerator. Similarly, in the overall denominator, we need to distribute. So 6 times x plus 2 times x over 3. X over 3 times 6 times x plus 2. And then minus this fraction here, 1 over 2 times x plus 2 times 6 times x plus 2. Okay. So we need to do a lot of simplifying. In the numerator, 1 over x plus 2 multiplied by 6 times x plus 2. The x plus 2 factors can cancel, and that just becomes 1 times 6, which is 6. So we've got 6 as the first term in the numerator. And then plus, here we've got to distribute the 6x through the parentheses to clear the parentheses. So let's multiply 6x by x and then 6x times 2. That's going to be 6x squared plus 12x. So 6 plus 6x squared plus 12x. There's our numerator simplified a little bit. As for the denominator, x over 3 times 6 times x plus 2. 3 divides into 6 twice. So this becomes 2x times x plus 2. 2x times x plus 2. And then minus, let's see here, 2 divides into 6 3 times, and our x plus 2's can cancel. So this last term becomes 1 times 3, which is just 3. So minus 3 there. Okay, so we've simplified the numerator and denominator a little bit. And to proceed, let's see if there are any like terms that we need to combine in the numerator. I don't see any, but we can rewrite the terms so that they're in descending order with the highest power of x first. So I'm putting the 6x squared term first, and then plus 12x. I'm just getting the terms in descending order, and then plus 6. As for the denominator, it looks like we need to distribute the 2x to clear the parentheses. So that's going to be 2x squared plus 4x minus 3. Okay. The very last thing to do is to simplify to lowest terms if possible. And that's accomplished by trying to factor the numerator and trying to factor the denominator, and then seeing if there's any common factors that we can cancel. So I'm going to give it a shot. I don't know if it will. You always have to try at the end and just see. Whenever there's trinomials, certainly you need to try to factor them. I'm noticing there's a common factor of 6 among all three terms in the numerator that we can factor out. So let's factor out that 6 there, and we would have x squared plus 2x plus 1 in parentheses after factoring out a 6. As for the denominator, there's no common factor, so maybe we can set up two sets of parentheses and try to factor the trinomial. So if it factors, we would have to think what times what equals 2x squared. That would have to be 2x times x. And then we would think what times what is 3. So that could either be 1 and 3 or 3 and 1. I'm just going to try. I don't think either combination will work looking at it, because if I put a 1 and a 3 in this position, we would have 6x and 1x, which will not add up to 4x. If I try it with the 3 and the 1 in the other position, 3 in the first factor and then 1 in the second factor, now we'll have 2x and 3x, which again won't add up to 4x. So the denominator cannot be factored. There's no way to factor the denominator. I'm just going to leave the denominator as is. I tried to factor the denominator and it did not work. It could not be factored. It's prime. So the denominator just needs to stay as 2x squared plus 4x minus 3. So there is nothing that's a common factor that we can cancel out, but we could just take it one step further and factor the x squared plus 2x plus 1. Because that trinomial factors, I believe, as x plus 1 times x plus 1, which is the same thing as x plus 1 squared, and then all over 2x squared plus 4x minus 3. There's no need to take this any further because we're done and there's no way to reduce, but some folks like to get it completely factored for the final answer. So we could write it as 6 times x plus 1 squared all over 2x squared plus 4x minus 3. So this is an acceptable final result. So is this back here. Actually, everything in this last line, starting at this boxed answer, here, here, and here, they're all acceptable and we can't go any further. That's method 2 for simplifying a complex fraction.